The question we are solving now belongs to test series 5. It is of control system subject. In specific, it belongs to root locus of control systems. As per the question, the open loop transfer function of a unity negative feedback control system can be written as g of s multiplied by h of s is equal to k by s into s plus 4 multiplied by s plus 5, where k is greater than 0. There are three statements given as related to the root locus of this control system. Or rather say there are four options given as related to the root locus of this control system. Option A says that root locus starts from -4 and -5 only. Option B says that root locus doesn't exist at the point -3. Option C says that root locus intersects with imaginary axis for k equal to 180. Option D says none of these. We need to pick the correct option out of these. We know that the root locus starts from open loop poles, that is 0, -4 and -5. But the option A states that root locus starts from -4 and -5 only. Hence, option A is not correct. Now let us consider the option B, as per which the root locus doesn't exist at the point -3. Now we know that on real axis, root locus exists at a point if the number of open loop poles and zeros to the right of that section is odd. But from the given data, we see that to the right of -3, the number of open loop poles is equal to 1, which corresponds to s is equal to 0. Hence, the statement option B is also not correct because it says that root locus doesn't exist at the point -3, but from our observation to the right of -3 there is only one open loop pole, hence root locus exists at the point -3. So option B is also not correct. Now we need to find the value of k for marginal stability because that is the point at which root locus intersects with imaginary axis. From the given data, we see that the characteristic equation is s cube plus 9s square plus 20s plus k is equal to 0. So now let us form the root array, which will have the entries in the first row as 1 and 20. The entries in the second row are 9 and k. Now the entry at the point marked can be written as 9 multiplied by 20 minus 1 multiplied by k divided by 9. That is 180 minus k divided by 9. And the entry at this point can be written as k similarly. So if we see that for marginal stability, k should be equal to 180 or 0. But from the given data, k is greater than 0. So for marginal stability, k should be 180, and this is the value of k at which root locus intersects with imaginary axis. Hence, the statement 2 is correct. So from the given data, we see that as related to the root locus of the given control system, the option C is the correct option.